Welcome back to episode 5 of writing a 6502 assembler in 6502 assembly language. The first thing to do today is to fix that little problem from last time, which is I had this issue of C strings and Pascal strings. As I mentioned at the end of the last installment, I want to move that to the file interface code so that my main assembler code doesn't have to deal with that at all. And in fact, I've already moved the code off screen, just copied and pasted it. So now what I want to do is go back and finish the job. So I'm going to look at this here. And here at the end, you'll see here's the code which changes a Pascal string to a C string right there. And then here's the code which changes the C style string to a Pascal string. All right, and what I need to do is just go up to call these routines in the appropriate places. That's all just test code we're skipping over for now. I mean, later it will be deleted, but for the moment, it can stay there. Here we go. So here's the create call, which uses a file name, a path. So right before we make this call here, we need to change this the C style string to a Pascal string. And to do that, we need to load X and Y with a pointer to the string. And right off the top of my head, that's going not. Oh, I see. That's in right. That's in command block +1 and +2. Right. That's in command block +1 +2. That's where it's put. So I can put here command block +1 +2. Change that to a Pascal string. All right. And then now what I'm going to have to do because of this, I'm going to have to push the processor status flag, push the accumulator, and then get them back because I have to preserve the error code if there's an error. So this is kind of painful. I will not deny it. P to C stir. So this code right here, I'm changing the path name or file name to a Pascal string. I'm calling ProDOS, and then I'm changing it back to a Pascal string. So I basically just have to repeat this for the other ProDOS calls that use this. So C to P stir. Okay. Push P, push A, pull P, and in between those two, okay, change it back to a C string. And this whole thing is, remember, just because I want to, in my main code, I want everything to be C strings, but ProDOS, the Apple II disk operating system, expects Pascal style strings, so I'm just going to change it around. And that way my main assembler code just uses C style strings and doesn't know anything about Pascal style strings. So here's another place where we have to do it. C2P stir. Okay. that, pull A, pull P. Okay. And if you don't remember what's going on here, that the pointer to the file name is in command block +1 and command block +2 for these particular calls, the open, create, destroy, and open. And I believe that's going to be it. Okay, because this is for read and write here. And I should maybe, right, and they don't need a pointer, they just need, they don't have a pointer to a file name. Okay, so that looks good. Let me exit that. And now I need to go back here, and here now I don't need to call these things, right? So that's going to go away. All right, and here this is going to go away. Okay, this is what I did last time. This is copying the pointer to the file name into f pointer, which is right here, right? It's the argument to this open call. IO buff is the buffer that ProDOS is going to use to read and write these things. I'm more and more thinking I ought to move this also into the ProDOS, into the file IO interface. I should abstract this away. My main code shouldn't have to worry about these things. But I think I'm not going to do that now. I might do that next time. Okay. So if there's an error, blah, blah, blah. And then we're going to close. All right. Let me just make sure. I'll go to the beginning of the file. Let me make sure by searching for this, it's not there. Okay. And I might as well search for this. Okay, it's not there. So now I've moved everything from the file AS0 to the file AS9. I've moved those two subroutines, C to P stir and P to C stir, and then I've also moved the usage of those into the ProDOS, the file IO abstraction layer that hides ProDOS and gives me my own interface to open files. Okay. Okay, so it looks like it works. If you remember, what's happening now is that the code is just trying to open each of the files listed on the command line in turn. If it successfully opens them, it prints the name on the screen. If it does not successfully open them, it prints an error message of some sort. So it printed out the names of the two files I specified, which means it opened them and closed them successfully. So that's what I want. Okay, so now our goal is actually to read and write from these files. So what we have to do is we have to make a character, a subroutine which will get a character from the file, get a byte from the file, but as they're supposed to be text files, get a character from the file. Okay, and we can call that maybe getC. And if you remember last time I set up this, here, let's load another file. I set up this in buff here. This is where we're going to, this is going to be 512 bytes. It's not obvious here, but that's what it's going to be, 512 bytes. And this is where we're going to read a block at a time from our file into this buffer here. And why is it in this file? It's in this file because AS9 is going to be the last file of last source file of the assembler. It's going to be at the end of the, when the assembler that I'm using, not my assembler, when the assembler I'm using assembles everything, this is going to be the very end of the binary image. The last 12 bytes of the binary image will be these right here. Well, then there will be whatever padding is necessary to get to a 256 byte alignment. And then, so right after that will be this buffer here. And of course, I'm going to have dynamically allocated memory of a sort, which will actually have to be careful not to step on this buffer. It will have to be here plus 512. So basically, I could almost go ahead and put that in here now, right? I can put here called break. Break is just the word that's used to mean the end of your image in memory, and make this a global equate to be inbuff plus 512. So this is where the end of my memory image is at the begin. And when I dynamically allocate, what I'll do is I'll just increase break, and then whatever memory is between the old value of break and the new value of break after I've increased it is the dynamically allocated memory. So I'll just save that. All right, go back here. So we need a getC or getChar routine. Okay, and I think I can put that here. Let's call it getC. I think my output is putC, so getC seems reasonable. This may or may not need to be entry. It depends on if I have the entire scanner in this file, but let's just go ahead and make an entry point for the moment. Okay, now this is going to need some data. It's going to have a pointer into the buffer that tells it where the next character it's supposed to get is. It can also have a pointer into it can also, I was just thinking about something about that break, but I'll come back to that later. It can also have a pointer into, or at least a count of how many characters are left in the buffer. I think I'm going to need both of those things, or at least it'll just be easier to have both of those things. So I'll have here a pointer here in buff P. I could see this being kind of in the code and being a self-modifying code issue here. Probably, maybe it will be. And count. IB count. That has to be 2 bytes because it has to be up to 512. So IB pointer and IB count. Okay, so what I'm going to do here when I want to get a character is I'm going to check out the count. And I suppose I should check the high byte first. Well, I just want to make sure it's not 0, basically. So I could do it like this. Okay. So if these two are, if it's not 0, that means I have. Okay, so I'll just call it getC2. That's going to be down here for now. So what I'm doing is this is going to have a count of how many characters there are in the buffer for me to read. If I read an entire block from the file, it will be 512 right after I do that. If I'm near the end of the file, I might not be able to read a whole block, and so in that case, it will be something less than 512. It could be 0 if my file is completely, ended, whatever. All right, so I'm going to just OR the 2 bytes of this integer, this 2-byte integer together to check to see if it's 0 or not. If it's not 0, I'll go down here and get a character. All right, and here's actually where perhaps I will, instead of having IB pointer, I would just have this right here. Okay. Right. Load from nbuff. Okay. Actually, this is supposed to be a 2 because 2 bytes. Okay, so this is assuming that there are characters. The count is not 0. I'm going to get the next character from the nbuff, which at the beginning is this address is the beginning of the input buffer, but I'm going to increment this right here. Okay, and yes, now I have to actually increment that. So I'll increment yeah. I'll just change this to IB pointer. So branch here, IB pointer, increment IB pointer plus 1. That's the low byte of this address here. Okay, if that did not become 0, then I don't need to increment the high byte. If it did become 0, I need to increment the high byte. Okay, and now I need to decrement this count here. To decrement, I can go ahead and load the low byte. And if it is not 0, if it is not 0, then I can go down here. If the low byte is 0, then I have to decrement both the low byte and the high byte. I illustrated this issue in a previous episode or previous installment, but the issue here when I'm decrementing is, suppose that the number I want to decrement is, in hexadecimal 0103. Then I can decrement only the low byte to make it 2. And again, decrement the low byte 1. Again, decrement the low byte 0. At this point, I notice I load the low byte right here. I see that this is 0. That means I have to decrement both bytes. So I'll first decrement this one and then decrement that one, like that. Okay, so I'm loading the low byte. If it's not equal to 0, I just go ahead and decrement the low byte. Otherwise, I first decrement the high byte and then decrement the low byte. All right. So here's where I'm getting the character from the buffer. All right, and then I decrement. And I can just RTS. I'm returning the character that I'm getting the character from the buffer. I'm sorry, here I'm getting the character from the buffer. This can't be load A because if I do that, I'll destroy the character I got. So let's just make that load X for now. Okay, so here I'm getting a character from the buffer. I increment this pointer here, which is in the code. Then I'm loading the count, the low byte of the count into X just to test to see if it's 0 or not. That's the only reason for that. Okay. If it is 0, then I'm going to decrement the high byte and the low byte. If it's not 0, I decrement only the low byte, and then I return and I have still the character I got from the buffer in A. All right. So this is a little bit, I mean, I'm having to increment a pointer and decrement a count at the same time. Not a disaster, but one could conceivably write this so that you don't have to do both things. But for that, I think I would probably have to have not a 512 byte buffer, but maybe only 256 byte buffer, which again is not a huge disaster. But I'd rather just read 512 bytes at a time because the file comes in 512 byte blocks. I don't know. It's just a choice. I'll do it this way. I think it'll be fine. Now, here we have the situation that the buffer is empty. Okay, the count of characters in the buffer is 0 when we are at this point right here. So we have to read from the file. Okay, so what we're going to do, the way we do this is we have to, and this is just my file interface that I have created. I need to get the count of how many bytes I want to read from the file in X and Y. And I need the file descriptor for the file in A. And then I need to JSR read. And then I need here, I need the pointer to the buffer that it's going to read into, which is going to be inbuff. Okay? Now we have to deal with the fact that the read could fail. But first I'll just say, okay, well, maybe it succeeds. So we'll go to getC0 if it succeeds. If it succeeds, the read succeeds. Now, I certainly hope that ProDOS doesn't throw an error because it hasn't read as many files as I asked. I guess I could go look. I probably should. Okay, let's take a quick look at that. Where is it? Did I close that window? I closed that file. All right, there we go. Okay. Let's go find the read call just to make sure. Okay, IO error, invalid reference number, and a file has been encountered, access error, file not read enabled, blah, blah, blah. Okay, it will be less than request not if EF was encountered. Okay. So it looks like it might give me an error. Into file has been encountered. Even though it successfully read everything left in the file, it just didn't read as much as I asked for. That's kind of annoying. But we'll figure it out. We'll deal with it. Okay, so this is the case where whatever, it succeeds totally. Or it succeeds, okay? We go here, we say, okay, carry is clear. That means the read succeeded. All right, so what we have to do here is we have to, we're going to store the number of characters read, which will be come back in X and Y, in this IB count. This thing right here, right? This thing. This will store the number of characters in the buffer. So however many we read out, here is how many are in the buffer. So we'll store that there. And now we need to reset this pointer here to point to the beginning of the input buffer. And we do that like this. So the low byte of the address of the input buffer gets stored into here, the low byte of this address, and the high byte of the input, that high byte of the address of the input buffer gets stored here into the high byte of this address. Okay, so we've done that. And now we can just fall right down into this code. It should work just fine. We've stored the count of how many we read from the file. We've updated, pointed this back at the beginning of the buffer, and then we can go in and get the character. All right. Now we have the situation here that we have an error. If we get an error, well, as I just said, looks like we're going to get an error if we hit into file. To me, that seems a bit strange. I mean, Product could just let us notice that the number of characters we asked for is not the number of characters we got. But anyway, so we're going to say there's an error here. So what I want to do first is just compare and see, is it this error right here? Is it the end of file error, which is hexadecimal 4C? Okay. All right, so if we get the end of file error, then I think basically I could almost just branch right down here, but I'm worried about the fact that I might have gotten 0 characters out of the file. That is, I'm truly at the end of file, right? So I want to read 512 bytes, but I get 0 because there's nothing left in the file to read. So I think what I need to do is check to make sure, this is supposed to be getC 0. I need to check to make sure that X and Y are not both 0. If they are, then it's truly the end of the file. And I need to return some sort of end of file indication, right? Okay. So let me make this actually 1 and 1. I'll make that getC 0. And this will be the case where we've got this end of file error. Like that. Okay. And now what I would like to do is compare X and Y to 0. And I suppose I should just do it like this. Let me compare Y first. If Y is not 0, then go down here, because I actually did get some characters from the file, even though it gave me an EOF error. And go ahead and if Y is 0, I'll go ahead and compare X to 0. By the way, I'm doing Y first because it's the high byte of the number of characters retrieved. Maybe it would be, maybe it's better to do X first, because it's more likely that X, yeah, if X and Y are not returning the number 512, then it's very likely, but they are returning a number which is not 0, then it's very likely that X will be not equal to 0. So if I check that one first, it might save me a little time, a very small amount of time. All right, so if X is 0, then I have to compare Y. Hang on a second. If X is 0, is there any way that X is 0? I'm just thinking, right, if it gets an EOF error here, that means it did not read 512 bytes from the file. That means the range of numbers that it could have read are, from hexadecimal point of view, from 0000 to Oh yeah, this is 256. Okay, yeah, this is 256 bytes. 512 is, oh yeah, okay. 512 is like this. So this is a possibility. It read 256 bytes from the file. Okay, good. So I do need to check this. Okay, so at this point right here, I have the situation that I got an EOF error and the number of bytes I read from the file was exactly 0. So now what I want to do is actually return something that indicates EOF. Okay? And I'm just thinking about how to do that. Yeah, one thing about my file abstraction here is that I'm still relying on the ProDOS error codes, which is not really ideal because it's not abstracting away from ProDOS. But my problem is I'm returning the character read in A, and theoretically at least, the character could be any byte from 0 to 255. I mean, a byte from the file. So how would I indicate the EOF? Well, you know, in Unix or whatever, the return from getC is not a byte. It's an integer, and -1 is out of the range of bytes, so it just returns -1. Well, I may change my mind in the future, but for right now, I think what I'm going to do is just go ahead and return at this point. And what this means, all right, so this is the situation here that we have EOF, but read some bytes. Okay, this is the situation here where we have bytes in the inbuf. There are bytes in the inbuf to return, or maybe just there is at least one character in the inbuf to return at this point. Here I got EOF, but I read some bytes. Oh, actually, this is not necessarily EOF. This is just read some bytes from the file. Exactly how many, I don't know. Okay, and this return right here is saying I got an EOF and there were 0 bytes read from the file, so it's a true EOF. We're really at the end of file. And by returning here, I'm requiring my code to check for this error right here. It has to check for this error, which is why I said it's kind of ugly, because I'm not really abstracting away from ProDOS if I make the code check for a 4C. I'm just trying to think, is there some other way that I can indicate an end of file Well, I'll come back to that later, I suppose. I would like to have some other way to indicate an end of file besides this thing here, besides checking this error code. I'm thinking about the V flag and the processor status register, but I don't think I can set that flag arbitrarily. Let me take a look. This is a my little reference. By the way, I'll move this down so you can see the website. There it is, www.maßwerk.at 6502-6502 instruction set. A very useful reference. And see, I can set the carry flag, I can set the decimal flag, but I can't set the overflow flag, so that's no good. Right? Setting the decimal flag would be annoying. I mean, because that changes how the processor works. I don't really want to do that. Well, anyway. So the way it is now, if I have end of file and there's actually nothing there, I'll return an error. Of course, I could change this so that it does not return the character in A, but it returns it in X and Y, right? I could use the Y register to indicate that it is an EOF in a sense. So in other words, I'm returning a 2-byte value just like you would do in other operating systems. Yeah, I'm just wasting time on this, and it's probably super boring to try to watch me think about what I want to do. Okay. So perhaps what I ought to do is just something like this. I have the character in A. Okay. What if I just load X with a 0 there, and X being 0 tells me that it's a valid character in A. And then what I would do here is just like decrement X. Or if I wanted to be all super Unixy, I would decrement X and Y. So I have F, 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 and X and Y. All right, and then at this point, I would load this into X, not into A. And then I would just use A to check this. And okay. Of course, it doesn't have to be. I could use Y here. So now what I'm doing is I'm having if I actually return a character, it's returned in X. So I'm returning just like you would in Unix. I'm returning a 2-byte value. Well, okay, old Unix, a 2-byte value. Where if the high byte is a 0, that means the low byte has the character that you've read from the file. And if it's in the file, you're returning FFFF. Because at this point, X and Y are both 0. Decrementing both of them makes it FFFF. Okay. I think I'll just do it that way. Now we have the issue of real errors here. Okay, so I see that there's an error. That's why I got here. It's not an EOF quote-unquote error. If it were, I would go down here and check to make sure if it's really EOF or not. So in this case, I am just going to return. So if there's some sort of error that's not an EOF error, And that could be any of these things here, an IO error because the disk is not working properly, invalid reference number, access error, file not read enabled, bad buffer address, blah, 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 all this stuff. Then it will just return here. And this is just an error of some sort that's basically unrecoverable by this code. So at this getC0, we have a situation that we have EOF, but maybe we read some bytes, right? And I'm actually not even 100% sure if ProDOS gives us this EOF error if it was able to read bytes. Maybe not. Maybe not. It's something I could investigate if I wanted to, I suppose. But for right now, I'm just going to say if ProDOS gives us an EOF error, then we will check and make sure if it actually read bytes from the file. If it did, then we'll ignore the error, right, by going to getCL1 right here. If it didn't read any bytes from the file, then we'll say, okay, that's really EOF, and it'll return FF, FF, and X and Y. So let me put a little comment here at the top. Okay. So this is where the mbuff is empty. Okay, so getC returns character from file in X and Y. I mean, right? Okay. We'll say from and returns the character from the file in X with Y equals 0. If EOF, then X is equal to Y is equal to hexadecimal FF, which basically -1. So basically it works just like, getC would normally work, where it reads a character from the file and returns as a 2-byte value. If it's a valid character, it's not EOF, then only the low byte matters, the high byte is 0. If there's an EOF, then it returns -1, which is just FFFF in both bytes. Okay. So let me just go over this quickly to make sure it looks good. Okay, load the count, check to see if it, or the 2 bytes together, check to see if it's 0. If it's not 0, then there are bytes in the buffer to get. And we go down here. Get the byte from the buffer in X, increment the pointer, this address here. That's these lines do. Okay, and then decrement the count, and then load Y with 0, which indicates that X contains an actual valid character. If the count is 0, that means the input buffer is empty. So what we do is we say, I want to read 512 bytes from this file descriptor, which is our file. We read it. This is where it will be read into, the input buffer. If that succeeds, we store the number of bytes that we read into the IB count. We reset this address to be the beginning of the input buffer, low byte, high byte, and then go get a character out of the buffer. if there is an error, then we first check and see if it's the EOF error. If it is the EOF error, we're going to go down here and say, well, let's make sure maybe, even though we got into file, maybe we read some bytes. So if we did, if x is not 0 or y is not 0, then we go down here and just act as if we read bytes. Just store those however many we read, reset the input buffer, this address pointed to the beginning input buffer, and go on. If it's 0, we read no bytes, then we're going to make sure that x and y are FFFF and then return. That will be our signal, our sign. X and y FFFF means end of file. For any other kind of error, we just return. And return the error there. I think I ought to do one more thing here, which is I ought to set Yeah, I'm just thinking, like, if I get an actual error here, not the EOF error, some other error, I'm just returning, so then carry is set, meaning there's an error. So what I probably ought to do here is clear the carry to mean no error. This is a case of it's, from my point of view, not really an error. Protos causing an error. It's not really an error, it's just that it's the end of file. So carry is clear to say there's no error. And here also, clear the carry to say there's no error. Okay. So now what I'm going to try to do is I have opened the file. Here's where I open the file. I store FD. Okay, and I print the file name. That's what this part is. So now what I want to do is I want to just try to read bytes from the file. So I load the file descriptor. Now when I read bytes from the file, okay, that's true. I'm only going to have one input file, so I don't really need to load the file descriptor. I'll just jump to getC, and it gets a character from the open file, whatever it is. Okay. Now I'm going to see if y is 0. If it is not 0, then that means it's the end of file. Which is here where we're going to close the file. Otherwise, I'm going to move the character, which is an X, to A, and just sort of put C, print it on the screen. So this is a loop. I'm going to read characters from the file until I get an EOF. If I get EOF, I'll close, and then I'll go back through this loop of getting the next file. Let's try that. Oh, that's that thing I was talking about the other day. This assembler gives me crazy stuff like that. All right, well, that's not so important at the moment. So I'll just get rid of this. And actually, it doesn't need to be an equate anyway. Right? I'll just get rid of it for now. It's not important at the moment. Okay. So let's try it with just AS0. Well, it looked like it started out nicely, but something horrible happened. So I'm going to have to reboot. And let's try to see what's going on here. Okay. So at this point, we print out the name of the file, which is maybe not necessary, but we JSR to getC, compare y with 0. If it's not equal to 0, we go to isEOF. We're going to load the file descriptor and close the file. Okay. Otherwise, we're going to take the character we read from the file, which should be an X, move it to A, call put C, and then just go back up here and get the next character from the file. So somehow, probably what's going on is we're not recognizing that we're at the end of the file. I mean, not that, we're not recognizing the end of the input buffer. We get, right, 512 bytes from the input buffer, and then right down here, okay, we load the count, check to see if it's 0, say it's not 0. Okay, so XY. Well, one thing that could be wrong that we should check is just make sure that here in the open, I'm sorry, in the read part, that we load the transfer count. Okay, we go to iPointer. This is the read write part right here. Okay, see, that's the problem. The transfer count is given back to us in command block 6 and 7, but I'm not getting it into X and Y. In other words, I'm not returning it to the caller. Okay, so I need to load X with command block +6 and load Y with command block +7. That's the transfer count, like how many bytes we actually read or written. I was depending on that being there, and it was not. Right here. Okay, so now that after we do the read, we can load this into X and Y. Now, what if there was a read error? Then carry will be set, and A will have the error code. This won't disturb either of those two things, so it's fine. We can go ahead and load this always. If there's an error, of course, it's not going to be any useful information necessarily, unless maybe it's an EOF error and it has however many files, however many bytes are read before the EOF. Okay, transfer count. Yeah. Okay, so we get that back there. Okay, that looks good. That might be all we need. Aha. That looks nice. Right? It printed out the entire file. Now, I think since I'm using the output hook, what I should be able to do is actually send this to the printer, redirect to the printer like that. And I can now pull up my emulated printer. And here it is, AS0. There's the contents of the file. Okay, let's get rid of that. And then try both of them, both files, just to make sure it works when I have two files in the command line. And it appears to, that's the end of the second one. Okay, so AS0. Okay, get command line subroutine. And there's the IO stuff. Now here's AS9, append AS9, and now we're starting AS9. Here's all that code from AS9. Okay, that looks beautiful. So I've successfully just read every character. I've just, what I've made is basically the program cat. You tell the file, it prints out on the screen. Okay, so we've successfully written a program cat. If I need cat, here it is. Right? Let's see, catalog. And yeah, I don't know if how do I, well, I can just do this. I can rename WSAS to cat and just reassemble to get WSAS back. So now I have a file, I have a program cat. I can just leave that forever. Another cat, foo, see what's in there. Right, that's the P2C store stuff that when I copied around. So now I have a cat program. Hooray! All right, well that will be all for today. Next time we'll start actually using this getC subroutine to scan the input and make tokens out of the characters that we get. So see you then.